Blackboard. On student resources. And then he has like a minute to get back. Chapter 4. Zoom. Stats, share, slideshow, play. Okay. Summary and data variability. This is what we'll go over. Measuring variability, range and mid-range, quartiles and interquartiles, variance, explaining variance, definitional and computational formula for variance, standard deviations for normal and non-normal distributions, and characteristics of standard deviations. That's just an overview. I don't have to necessarily write that down. Variability ranges from 0 to infinity. It has to do with how scores vary. And some of you have written like, in some of the assignments, I want to know how we use stats in the real world. Well, one way, which I don't really enjoy, is I work for this school online that I like to call Walmart, because their pay is pretty low. And they're very demanding. And they're on my case because every single year they review me and they're like, well, you're giving out too many A's, or like there's still not enough variance with your grades. Like I thought, what? Yeah, they're like, don't tell students to fix their grammar. I'm like, well, it's college. Like, are you kidding me? Like, they're kind of crazy. So variability, like we can talk about like quantitatively, because they're like the scores need to vary, or qualitatively in the sense that for literally like 6 years, I would get a different reviewer every year. They would give me goals, and then I would get flagged against the goals I set with the previous reviewer and the new reviewer, which was super fun. But variability, the variance in the scores, like they're running reports and then being like, well, there's too many A's or too many B's, or like, how about you just let me do my expletive job? But whatever, you know. So, but I don't want to say no to money, so I continue to work for them. But someday in the future, or if I win the lottery, I may just say no, because I don't really appreciate all the demands. And they're literally the lowest paying school out of everywhere I work, and they're the most demanding. So yeah, I just did a survey and sent it to them, see how that works out. I also told their lead faculty that I was so confused, and then they like blacklisted me for like 5 months before they gave me a class, and then they created some faculty lounge that would like give you all these tips to do whatever the heck they wanted, but it's still super unclear. Because money's still green. Like, let's not watch football.
It's not football.
Let's not watch sports. And what class is this? And is statistics and Spanish the same thing?
No,
would you like me to lecture in Spanish? Would that be helpful? So we could do that.
Just do it 12 p.m. tonight. This class goes till 10 p.m. So
it's better time management. So again, just how scores vary. So basically, what we're talking about. Really need to know that out. Just kidding. We're in back in. So if we have these scores don't vary, those scores do vary. So basically, all we're measuring is the amount of variability or variance. So if they're all the same scores, or if you think about like Dancing with the Stars or any show you might watch, they all score exactly the same, no variance. And then it's how much they vary. So we have range, largest to smallest, or actually highest to lowest. That is the simplest way to describe how the scores disperse from each other. Thank you. Most informative for data without outliers. So range doesn't tell you about the variance much when there's like a random high and low and we're not watching Spanish. Right? So, for example, if we want to look at the range of these scores, 5 minus 1 is equal to 4. That's the range. From the highest number to the lowest number. 2, 4, 6, 8, and 100. 100 minus 2, 98 is the range. I think we talked about the range before. So there's the real range and then the regular range. So the range is just highest minus lowest, or largest minus smallest. That is your range.
But real range is minus or plus one of that.
Yes, real range is +1. Yeah, real range is the same thing. Real range is always +1. And the way we get that, if we say 5 to 10, 10 minus 5, 5, that is our range. The difference for the real range is this goes to 0.5 less, and this goes to 0.5 more. So there is 10.5 to 4.5, which ends up being 6 for the real range. That's what they call. That's why you add 1. Then we got that so far. Is that making sense? Just range. Fractiles measures divide. So my example with Walmart, we won't tell you the name of the school. That's very much a way to screw with me with statistics. Very irritating. Fractiles, because like I have really good reviews from students. Like, you don't need to be all up in my business about how I grade. Fractiles, basically just cutting things in half. So cut it in half once, you get your median. Quartiles 4 times, deciles 10 parts, percentiles 100 times. Does that make sense so far? Are there questions on that? So we're not watching Spanish.
I'm not watching it, I promise. I'm just, sometimes the thing comes up, I just click it. I'm not watching.
Because if you're gonna watch that, you can't ask me questions.
Okay,
Like if you're confused, that's on you because you're doing something else in class.
I think that's fair.
Like if you send me an email because you don't get it, that's on you. And I want to help you understand, but you got to pay attention. In terms of, so quartiles and interquartiles. So lower quartiles, 25th percentile. I'm going to show you this like visually in a moment. 50th percentile, median quartile, 75th percentile, quartile 3. So how do we do that? So far, locate the median for all the data. So like your midpoint, that's the median quartile, quartile 2. Lower quartiles halfway, upper quartiles halfway between that. And this is a much better way to explain that. You see what that looks like. So we have, there's 7 numbers. There's 3 and 3, and right in the middle, that's that quartile 3. If we go right here for quartile 2, we have 1, 2, 3, 4, 5, 6, 7. We should have 1, 2, 3, 7 on that side. So just splitting that in half. Quartile 1, same thing. We got 7 numbers, and then it's one right in the middle. So it's literally just cutting things in half a whole bunch for your interquartiles. So semi-quartiles are cutting things in half more. That's all we're doing. We're just taking a range of numbers and going, where's our midpoint? What's our midpoint of that? What's our midpoint of that? And so on. So interquartile range, 75th percentile minus 25 percentile. For example, interquartile range, 92 minus 76 is 16. Now, where do we get that from? Well, we're eliminating the top and bottom 25%. So if we go back and look, so that was 92. So we're taking this quartile minus that quartile. So 3 minus 1, quartile 3 minus 1. And their interquartile range is 16 because there's the 2 quartiles. Yes.
Okay, if you were to find the interquartile range, you would need to know all the numbers you have.
You'd have to have the numbers, yeah.
You can't just clarify. You wouldn't be able to solve that unless you had.
That's correct, yeah. Because like, if we go back to the slide, like, they're all listed right there. So you'd have to have it, like, I would list them lowest to highest, and then start finding the middle point, and that's how you would continue to find your quartiles. Semi-interquartile range is you cut that in half again. So interquartile, we took quartile 3 minus quartile 1, 92 minus 76. That difference or that range was set 16. semi-interquartile, we divide it by half, and it's 8. The quartile's making sense. It's literally just like taking your numbers, cutting them in half over and over again. I can go back if you need me to on a slide. Anybody? Yeah, this one or one more. First one, like this. So you can see that. What? One more? No problem. Give me like that. What do you need?
Go for it.
Go forward, like this.
That one.
Gotcha. Okay. Yep, no problem. So you're you're semi-interquartile, yeah.
There's a question about the previous slide.
Yeah, this one, right?
When it says 92, in this specific example, everything's up to a 92, right? Like,
It's right here.
yeah, just because ideally, you would measure out of 100, right?
No, this is just a list of numbers.
Just this specific example out of 9 is for 92, right?
Well, we have 62s our lowest, 98s our highest. There is no 100.
Yeah, but in this example, it's just these set of numbers, right?
It's just these set of numbers. So we have a list, so we list them in order. So 98's where it stops. And if we go directly smack dab in the middle of our list, we get 86. We go halfway between 86 and 98. We get 92, which is very easy visually because we got 3 and 3 on each side. And then same thing with quartile 1, 76, right between 86 and 62 from the list of the numbers. And then that's right in the middle.
So you always cut it in the middle first.
Yeah, I
Cut it
would-
in the middle first, but that's not gonna be the 2-1, it will always be.
Q2, yeah. Or your median, yeah.
Would there be 4 quarters? 1 to 25, 26 to 50, 1 to 74, or 75?
Your quartile 4.
Oh, because
You don't really list it, but there would be 4 get you up to like 100, not to necessarily 100, but to 100% of the numbers. Make sense? So variability for average square distance across scores, deviate from mean. Value can be 0, no variability, or greater than 0. Negative variance is meaningless. So the variance is how much the scores vary away from the mean or the average. So just how much scores are to like the left or the right of the mean. So variance is dispersion of scores to the mean. Calculate the numerator, the sum of the squares first, divide by the denominator, and then that's for population variance. Or for sample variance, it's the same except it's n-1. These both formulas work. I really like this one for population for variance and this one for sample, because you can do those pretty easily. Because we go into Excel, if we go into, assume I have Excel. All right, so let's create some main number. 12, and what's yours? 12 and 74, okay. 12, 74. Six more numbers over here. Just randomly make them up. Give me a number. Just don't make it like huge, like hundreds or thousands or
3,
fine. 3. Another number.
6,
6,
8,
8, 34,
30,
30 Fibonacci, 34, 8,
21,
21 Fibonacci, yep. 28,
3,
3, another 3,
5,
5,
10,
10,
25,
25,
31,
31,
7,
7,
11,
11.
13.
18.
Hector, you got one? 20? Anybody else have a number they want to throw out here?
99.
But it doesn't matter how many we have, just
22.
22? 32? Is that a pretty good list? You want to add a few more?
That's
Okay,
so many.
perfect. All right, no, this will still work. So if we're trying to calculate variance, it's the sum of the squares divided by n. So how do we do that? Well, we got to do a couple things. First of all, I would probably insert. So that we're going to call this our x or our value. So if we take these numbers and we want the mean, we just sum these. We have 512. And we clearly have 23 of them, right? Because it counts for us. So we can take 512 divided by 23. So let's put our mean. So let's put our mean down here. Let's put our mean equals mean. So we'll go equals 824 divided by 23. I'll agree that's the mean, right? Makes sense. You want to be fancy, you could certainly type in equals average. Average. And then you could just take all of them, highlight them except for 512, obviously, because that's not part of it. That would also give us our mean, same thing. Well, it's pretty close. I mean, yeah, that's pretty close. So everybody's with me so far, right? So then what we want to do is we're going to do x minus m. Yeah.
Sorry, so when you're talking about variance, what is the excess stand for?
Sum of the squares. So I'm going to show you how to get to the sum of the squares right now. So x minus m. So that would be equals a2 minus, what's our mean? So minus this one. 29. Right. So x minus m. So we should be able to fill it down. That should work. Fill. Yeah. So all I did is I just did the value of x minus the mean. Now I'm going to do x. I'm going to do x minus m squared, which is pretty straightforward. So that's going to be equals a2 to the second power. That's going to be b2 to the second power. b2. So we're going to square that. That makes sense, right? Okay, so then let's see if we can fill. I think we can just fill down. So those are the squares taking the value minus the mean. And then if we take all of these that are now all squared and we sum those, we now get the sum of the squares, or SS, sum of the squares. Does that, those steps make sense so far? SS or sum of the squares. So variance is equal to the sum of the squares divided by n or divided by n minus 1. It's n minus 1 if we're dealing with the sample. It's n if we're just dealing with the population. So we could take this. So if we wanted to know what our variance is, we could say equals C24 divided by, there's 23 of them.
How do you enter this menu that allows you to add and subtract stuff? What button do you press?
Equals.
Wait, like, so you know how you're basically doing the math for everything in one tiny square thing?
Oh, so what I did is so like this one, I put the formula in, but I put the $sign here.
You know, where do you type, what button you press so you put the formulas?
Equals. Equals. Start with equals for everything. So that's our variance, 486.36. Or, but that's actually our population variance, right? Makes sense because it was over N, pop variance. So our sample variance would be the same thing, except it's going to be N minus one. So it's going to be divided by 22, right? Because we're going to take one away from our denominator. Makes sense, everybody, so far? So we're going to say that is equal to C, that is equal to C24, that's our sum of our squares, divided by, then we could do parentheses, we could say 23 minus 1, it would work. And that makes sense because the sample variance and the population variance should be close, but not the same. You had a question, Nikki? Absolutely, yeah. Now, if we want to be fancy, we could do the population variance up here if we wanted to. And then if we go back into Excel, you go into your announcements right here. Excel formulas. So we have, where's the standard deviation? I sworn the variance was in Excel formula. Okay. All right. So that's how you get the variance. Sum of the squares over N population, or sum of the squares over N minus one. So let's go back to that. Does that make sense so far to everybody? Now, if you look at these closely, I kind of just did this other formula, the sum of X minus M squared over N minus one. I literally just did that in Excel. Or they're basically the same thing. So computing variance, here's another example. Compute the following variance. So you take all those numbers, and then you get X minus M, the sum of the squares, and then you add them all together, that equals 46. 46 divided by 6 different numbers, 7.67, or the sample variance, 46 divided by 6 minus 1 or 5, 9.2, and the variances are going to be very close. Now, the reason that that happens is, remember, if we go back and we look at this, we go a little further down, and we look at, pretty sure I put it in here. Or maybe not. If we go into this class with the announcements, we scroll down, it's right about, where's the pretest? Channel. Come on. Really? Okay, I guess it's not working. Okay, that's fine. Back. So that'll make sense, putting the variance. So why do we do that? 3 reasons. We square the deviation in the numerator. The sum of the difference of the scores, remember from last week, is 0 if we don't square them. Remember when we got to 116 on the worksheet? As I'm sure none of us are sending text to our friends right now while we're in class. To avoid each deviation squared to produce the smallest positive solution. Sum of the square differences from the mean is minimal. Squaring the deviations gives you minimal error. Squaring the scores can be corrected by taking the square root, because the standard deviation is the square root of the variance. What does standard deviation mean? We say this is a traditional model of intelligence. Everybody's around 100, that's average. Standard deviations are basically like clustering of scores. So it's usually about 15 points, by the way. So 85, 70. 115, 130, 145, etc. What you can do cognitively in terms of standard deviations on intelligence, you do a lot less cognitively if you're rocking 85 versus 100. The fact that you're here, you're probably all 100 or higher. You can do a lot more cognitively at each deviation. Yes.
One question about the slide before this, when you gave the example of configured variance.
Mhm.
and the terms on the square, why are they all? Is that?
That's, what do you mean? Where?
In 505.
Because the mean was 5.
Okay, that's what I thought.
Our mean was like 20 when we did it, or whatever it was. Was it 20 or?
I don't get it when you do it on the computer. I was just checking. I get it when you do it like that, but when you do it on Excel, I don't get it.
So what we did is our mean was 22.26. So if you look at this, their mean was, because somebody take 5, 10, 3, 7, 2, and 3, add them together and divide by 6, you should get 5.
Yeah, that I get.
So that was x minus,
Then you subtract the 5 from all the numbers.
yes. So that's the x minus m. So you get all those numbers like we did on Excel. Then you'd square all of them, which they did.
And that's what you get the 25, the 4.
Mm-hmm. Yeah, because they're squaring those differences right there. And then the sum of all the squares
46
is 46.
divided by 100 comes to 0.
Yes. And then the one below is the sample.
Like plug everything in.
No, the one below is sample variance.
Oh, yeah, but like, but now when you just plug everything in,
Yeah,
like, yeah, like the same numbers that you use for population.
yeah. Yeah, that makes sense in the slides on the Excel or vice versa.
Yeah,
That's fine. Yeah. So does everyone have this so far? So the sample variance is unbiased estimator. On average, the sample variance or probability variance, you subtract 1 from is an unbiased estimator, the sample statistic from a randomly selected sample. The idea is as respect to the population parameter. If you remember that thing I showed you where I was like, take sample, and all those green balls on the left and right would fall down in terms of like how close it is, because the idea is if you do the sample right, it's representative of the population. If you do it wrong, it's not. Like if you survey people in a highly democratic area trying to see how they voted, it's going to be biased. You'd want to survey moderates, Democrats, Republicans, and then see how they voted, so that the sample will mimic the population. So here's an example of some scores here from 2 possible samples. So the 2 possible samples are AA, AB, AC. These are the scores in the sets. C is S squared, which is your variance using N. So we took so A is 8, B is 5, C is 2. So that's our mean. Our population variance is 6. Our sample variance is 5. If you don't subtract 1 from the denominator, you get a biased estimator. Population variance is less than the sample variance, which we just did on the Excel. So a -1 increases it, but your population variance and your sample variance should be close to each other, respectively. You deal with large numbers, there's a bigger difference. Smaller numbers, they should be closer together. Then we have degrees of freedom. Number of scores in the sample that are free to vary. All of 1 is free to vary. So we're talking about variance. So if we have a list of scores, like put these are all 1s. There's no variance. Variance is 0. But if we have 1 and 2, the 2 varies. Or 1, 2, and 3, these 2 vary. So the degrees of freedom is n-1, because you know the mean and the value of all the scores except 1, and then you can perfectly predict the last score. We're going to practice, don't worry. So again, same idea, calculate population and sample variance without the mean. So the sum of the squares is equal to the sum of the value squared minus sum of the value squared over n, where the variance or theta squared is sum of the squares over n. Computational formula is the sum of the value squared minus sum of the value squared of n, where sum of the squares over n minus 1, basically the same exact formula. So for example, yes. Yeah, of course. I never restrict that. But no hiccups today, okay? Substitute values in the formula for the sum of the squares. So you see we have these right here. We have all of our x values and we have our x squared. The sum of the squares is the same for the population and sample variance in both definition and computational. So the sum of all the squares was 6,800 minus 996, which is the sum of all the values squared over 20 values. So the sum of the squares is equal to 11,199.20. Is that making sense? Just kind of looking at it on the slides. Okay. Standard deviation, you just take the square root of the variance, or it's the square root of, it's just, and that's your population or standard deviation. We usually write the sample variance like that, and we write theta for population, or like I said, or we square root it, and that's our standard deviation. So if we go back into Excel, so we got our population, our variance, and our sample variance. Well, if we want our standard deviation, population, standard deviation, deviation, variance. All we got to do is take the square root, standard deviation, not variance, standard deviation, sample, deviation, sample. So you can do it, well, you can do it a couple different ways. You can say, well, this is equal to G11, which we're referencing the cell, but it would actually be equal to SQRT of G11. Square root, standard deviation right there. Or same thing, equals SQRT, ref SQRT, and that would be G12. And that is your standard deviation. They're close. That makes sense. So what if we want to do this a little bit differently? Well, let's do it again. Let's do standard deviation. Let's do SD percentage, SD population. And let's do SD sample, standard deviation sample. Well, we can go over here and we can just go equals ST dev dot population of, that's right, yeah, equals ST dev dot P of all of these values, leaving out the 512, of course. There's our standard deviation population. That's pretty close. I mean, that's like versus by hand. I mean, we're talking about like decimal differences. And then the same thing with the sample, we can say equals standard deviation dot sample. And then we take our numbers, highlight all of our original numbers, and then enter. And that's, so that's pretty close. And we're talking, this is like what, off 0.5. So you can do it in Excel or you can do it by hand. The reason it's probably off is like rounding or only going some decimals. When we do it by hand versus having Excel do it, because Excel is probably going like several decimals to the right. That's why it's slightly different. But generally speaking, they're gonna be pretty spot on. Unless I calculate something weird. This is right, C24 divided by 23. Oh, I bet you if I go like this, it'll probably be like different, maybe. No, that's right. That's standard deviation. Yeah, you get the idea. Slide. And of course, it wouldn't be complete without. You can also open up SPSS and do the exact same thing. So I can take, if I want, I should be able to take all these values and do Control C. Yep. Control C and go to SPSS and Control V. And then just let's clean that up and call this random numbers. Only decimal 0. Well, that's a little bit better. Well, we can also go analyze, script statistics, descriptives, random numbers, options, standard deviation, variance, range, continue, okay. And it'll tell us just like that. Or you could take you could also do analyze script statistics, frequencies, random numbers, statistics, mean, median, mode, standard deviation, range, quartiles, percentiles, 2 quartiles, continue, okay, and it does the same thing for you. So you definitely want to know the formula and how to do it by hand, but you can absolutely use SPSS or Excel to check your work.
And we have to, or we could.
You could, yeah, as long as you know how to get there on the test, you're fine. Right. So standard deviation, continue. Come on. We do the standard deviation for the following scores. So our X values in the sum, then we square all of them, we have the sum. The standard deviation is 154.83 minutes in the sample. If you compute the mean for the sample, you'll find the mean is 430 minutes, or our average. The standard deviation tells us the distribution of all times for students, other than those responding at the mean, deviates an average distance of 154.83 minutes from the mean. So we'll talk about how you interpret that. It's like the clustering of behavior typically with a standard deviation. Like they found, we talk about like intelligence scores, you usually do more at each standard deviation, usually about 15. So computing the standard deviation from above scores, population variance, sum of the squares over n, 215, 750 divided by 10 is 21575. Where do they get that from? 15. And then you would square root that, sample variance, with the same thing, except you divide by 9, and then you do the standard deviation with the square root of it. So there's some rules, at least 68%. So when we talk about normal distribution, I'm talking about a bell curve, like a nice round shaped bell curve, symmetrical. At least 68% of the scores lie within two standard deviations of the mean, 95% lie, 68 within 1, 95% lie within 2, and 99.7 scores lie within 3 of the standard deviation of the mean. So what does that mean? It means is we're saying out of all the scores, if we have our perfectly shaped perfectly shaped bell curve. Let's just say we'll do the same thing. So that's 85, that's 70, these are 15. Standard deviation points, 130, 145, and this is 55. It's saying that 68% of the scores will be within one standard deviation. 68% of the scores would fall here. 95% of the scores would fall between here and here, 95%, and 99.7% would be within 3 standard deviations of the mean. And if they don't fall that way, the curve doesn't look like that. It's because it's normally just distributed. I believe. Yeah, that's exactly what I drew. So can you see what? So like that's, so these are, in this example, it's 4. So between 8 and 16, 68% of the scores, between 4 and 20, 95%, and from 0 to 24, 99.97%. Just where the scores fall underneath the curve. Making sense so far? Some characteristics, standard deviation is always positive. Even if we go to the left of the mean or 0, it's still always referred to as positive. It's one standard deviation to the right or the left. Why? Negative variability is meaningless because it's based on how much the scores vary. So you really wouldn't, if it was 0, there wouldn't be any variance, there wouldn't be any standard deviation. Standard deviation is used to measure quantitative variables, numeric value, describe variables measured in numeric units. You would never use standard deviation to talk about nominal variables. You just simply wouldn't. You would just sort and classify those. Far so good? Sounds anybody taking notes? Standard deviation is the most informative when reported with the mean. Reporting the mean and standard deviation can inform the reader of distribution of the data. It's always going to be recorded like this: mean plus or minus standard deviation. Or you might see some numbers: 115 plus or minus 20, mean plus or minus standard deviation. So when you see this, think that. They always list it like that. There's stuff in WebAssign like that. It's always mean first plus or minus standard deviation. The value for the standard deviation affected by the value of every score and distribution. Adding and subtracting the same constant to each score will not change the value of the standard deviation, just like with the mean. So if we add the exact same thing, that doesn't do anything because remember, the mean drives the variance, which drives the standard deviation. So if we change everything by the exact same amount, it doesn't do anything. Multiplying or dividing each score using the same constant will cause the standard deviation to change by that constant. Very similar to the rules we talked about last week. So if we're dividing it or adding or subtracting the same amount, it won't change it. And then whatever we divide it or multiply it by, it'll move it that amount. Does that make sense, everybody? We got some worksheets coming up. Got an easy one and then a difficult one, but I'll walk you through it. Don't even sweat it. So let's go into student resources, in-class activities, and then I think that's right. This is the one that I want. Yep, that's the one that I want. So we'll go homework, edit, homework, 9/22, 22, submit. And we'll go make available. You should be able to see that now. And it should say homework 9/22/22. And then you should download this worksheet and then just do a little bit of work in groups. Based on what I just told you, try to work on that worksheet and then I will walk you through the answers. And no, it's under student resources. Student resources, in-class activities. And then you should see something that says homework with today's date. Try refreshing, yeah. Crap, am I? You're right, you're right, I'm in the summer, that's why. You're right.
28.
No, I got you. Don't worry, I'll fix it. Student resources, in-class activities. And it was this one right here, edit. It's gonna be 9/22, 23, 9/22. Submit. And then we're gonna go available. And then you should see something that looks like this.
Bless you.
So we're gonna look at what are the degrees of freedom located in the denominator of the sample variance formula. You have your hint. Just doing questions 1, 2, and 3. So give you 5 or 10 to work on your own or with each other. And then we'll walk through the answers together as a group and how we got there. And if you're really, really stuck or something, just raise your hand or talk to me. And or like I said, we'll review them in a few minutes. In-class activities, today's date. 9/22/22. Try refreshing. We just made it available. Degrees of freedom are the since denominator part of it. Where does n go in the denominator? What do you do with n to the degrees of freedom? So back 1. So that is 50. First one would be 49. No, minus 1. So it's the denominator.
Oh, yeah,
Degrees of freedom.
okay.
Because it's giving you the n. for arrow number one,
Uh-huh.
it has to use a degrees of freedom, so the degrees of freedom is just an anomaly.
Oh my God.
That was actually really.
Yeah.
You know, when you think of it,
This is what I- this is what I- this is what I-
That's why we're. constantly recording. Degrees of freedom. So that's 49. Most of the south side is 20. Doing the following very. For each of them. Some
Number of observations.
but I'm asking what some of the squares are.
I know I
Twenty,
think it's
twenty,
changed.
Oh my God.
Follow
Oh,
those.
man, that's gonna be-
So, see, my worksheet that I. So all we're doing is just like, we're doing very. No, you're just doing the denominator. I think that's the answer.
Wait, where can we find the, you put me on for the formula, where is it?
What?
I cannot seem to find it.
It's,
Dude,
yeah, I think I'm-
is it the master formula?
I was doing the same thing.
Where?
Okay.
Right here.
Now we have to-
And what is that? What's that?
So can you see that? So these are all
Generally.
one less because it's n minus one. These are all the same because it's literally giving you what it is because the sum of the squares, because it's the formula. The sum of the, if I erase that,
The DF is
The-
equivalent to N.
it is equivalent to n minus one degrees of freedom.
So which one I keep, the monitor's blocking?
Oh, okay, let me.
Wait, so.
So all we're doing is it's just asking you the denominator, so the first set, the degrees of freedom, it's n minus one and they gave you n. So every single one of those,
49, 9.
Yeah.
11. That's it?
that's it. This one's really, really simple.
Bruh, let's try.
Do you see that? You guys see the answers? I can zoom in. And then the reason for number two is the sum of the squares of the degrees of freedom. Well, this is the formula and it's asking you what this is. Well, you could put the 20 down here, you absolutely could, but it's asking you what the sum of the squares are, which is literally just the exact same. Like,
Why would it be the exact same?
no, it'd be over n. No, the publisher got it wrong. So you would take this, you would take each one of these and divide it by
20.
20. Yeah,
Oh,
yeah, that's right. Yeah, divided by 20. Yeah, sum of the squares divided by 20. Yeah. So all of these divided by 20 would be your answer. See, every once in a while the publisher gets it wrong.
okay, so for example, for the first one, it would be 4.3. Yeah.
But remember, degrees of freedom is n minus 1. So that would technically be 19. Right? That would technically be divided by 19
For all of them, right?
for all of them because we're dealing with degrees of freedom, n minus 1.
So we're dividing them by.
N minus 1. This degrees of freedom is always n minus 1. Because the scores can only vary by, because the first number can't vary, so the degrees of freedom is always n minus 1. So you're dividing them all by that, and then it's the same thing for that's the sample variance, and then we select sample size of 200. And then this number 3 is the same thing, but you divide it by 119. No, 199, 200 minus 1 for the last one.
So you, but you divide all of them by the.
For number 2, yeah,
Yeah, for number, I'm
Yeah.
sorry, number 2.
yeah, you divide them all by 19, and then whatever those numbers are,
I'm still confused for what we do for number 2.
what would the sample variance be? We know that the sample variance is equal to the sum of the squares, which they're giving us, which is that first number, that's our numerator, divided by n minus 1. We know n is 20 because they gave it to us.
Yeah.
So we're going to take this number that they gave us, that's basically our numerator, or sum of our squares, and divide it by 20 minus 1, which is 19.
So all we're doing is dividing everything by
By
9.
19 because we're using this formula right here. And then whatever these equal would be your answer.
Wait, for number 3, we're doing that same thing, but we just changed the sample size?
Yeah, so they gave us 200, so n minus 1 would be 199.
You want us to round it to the nearest what, please?
Like to the nearest 10th or 100th is fine. Don't do more than 10th or 100th. Because WebAssign and the exam's not going to ask you to go further than that.
So number 3, it's those same numbers.
Well, this is a sample size of 200 now.
Yeah.
So it'd be, our degrees of freedom would be n minus 1, so it'd be 200 minus 1.
But it's those same numbers from up there.
It's the same numbers from up, it's the same numbers from up there,
Okay.
but you're dividing them by 199. And then whatever the answers you have, rounded to the nearest 10th or 100th place, are correct. We're just doing variance, sample variance. Do you have a question, Janet? Go ahead, ask, or I can come over either way.
On my worksheet, it says that I'm the.
Oh, because I changed it. The sum of the squares on the number would be the numerator on the top. They're basically giving that to you because it's this formula or that formula. So the numerator is just basically like listed. If you actually calculate the variance, then you divide it. Does that make sense, or have I totally confused you? Yeah, to understand the variance, yeah. I changed it because of the answers being the same. And now I'm changing it back. Yeah,
So for number 3, we just do the same, except we divide it by 199.
by 199, yeah. I can change that on the worksheet if that would make it easier. The question on my worksheet. On this. We'll just delete this. And then it'll make sense. Save. And then we'll go back in. My institution. Stats. Student. In class. Edit. Mark for removal, browse. Okay, I fixed it. Now they're all asking for variance. on number 2. I just updated it.
I was turning
No, do the variance, divide them.
oh, I did that.
Yeah, that's fine. That's fine.
Go back and forth.
I just don't want you guys texting. If you're using your phone for the calculator, it's fine.
What did you change?
Yeah, we'll do it right now. Or whenever you guys are ready.
What did you change?
All I said is I said just calculate the variance. So it's literally like the math. So 86 divided by 119, whatever that is.
199.
For 3, yeah, not for 2.
Yeah, that's what it is.
Calculate.
I just changed like.
86 divided by 19, 4.52. Or 4.53 if you round. 121 divided by 19, 6.37 if you round, yep.
And then 7.5.
Does everyone have 7.58?
Yeah,
17.32.
we went around, I just did 17.
Yeah, that's okay too.
31.58.
1.58, yep.
And then the next set.
So the next set, we're gonna do the same thing with the numbers, but we're gonna do it divided by 199.
0.43. Then 0.61. 0.7. No, 0.
No.
Gotcha. 0.61.
And then 0.72. 1.65.
That's about right.
3.0.
That's it. And I don't think there's any more to that worksheet. I'm pretty sure that's,
Yeah.
You want
That's
to
it.
start right now?
yeah, or soon, but yeah, that's it. That's the easy worksheet. And now we get to get into the more complicated worksheet.
Oh,
No, it's actually fine. It's way less. It is, but I'm gonna walk you through it. Infographic. In-class assignment.
You get notifications anytime any of us submit an assignment.
If I turn that notification on,
Oh, okay.
I don't have that notification on because I have the notification on. I don't,
It would drive you crazy. Yeah.
one of the schools has, a couple places already have it on. I get a ton of emails already. And I'm like, I'll just grade it, whatever. Either's fine. Just don't do pages. Anybody? PDF or Word's fine. I can't read pages. Like you'll get a 0. Like I don't want to give you a 0.
You mean
But
like writing?
no, pages is like a format.
Yeah, like on like macro, like Apple for like Pages, which is kind of like Word, but like Microsoft Word, but it's the Apple version, I guess.
Oh, I see.
Yeah,
But he can't read it.
which is weird because I have an Apple.
Yeah, that's kind of weird that you can't read it.
What? Docs, DOCX, DOC, PDF, all fine.
Usually I send them PDFs because I just check the
Yeah, PDFs are easier. I just want to be able to read it so I can see you did the math. That makes sense. And then the next thing we're gonna do, and if you'd like, we can take a break or we can keep going, depending on how you're all doing. Quick break, like 5. So it's gonna be in class. This is gonna be in class assignment 3 and 4 center. In class assignments infographic, and it's below the infographic assignment.
Wait, it's called in-class assignment 2, Igor?
No, it's right here. I'll show you. No, that's what we just did. We're doing a different assignment.
Oh,
So you're gonna click student resources. I'll show you where it is, and then we'll do the assignment after break. In-class activities, and then you're gonna scroll down to infographic. In-class assignment 2, infographic. And then below it, you have this assignment right here, in-class assignment 3 and 4. And then it should look something like this. And it's a review of chapters 2, 3, and 4. and we're gonna do all that stuff in Excel.
It was due, June 30, 2022. I think we're ready.
Well, you get them, better be working.
I guess you better, get cracking.
So are we taking a break?
Yeah, let's take 5, so
Hey, let's go through.
you guys are hiccuping
Let's
2 weeks in a
do-
row. Suspicious. I'm not gonna kick you out,
You
just
don't know
level,
what's in this bottle here, Professor.
just level with me.
No, we'll give you some if that's what you like, or,
Yeah, if that's what you're looking for.
I'm sure I can still teach stats, but I don't think they're very professional of me, so no.
You want to take a look at this bottle?
I'm just saying the hiccuping 2 weeks in a row was weird.
I mean,
Deal with
I
it when
think
they
you're
drink.
a professor too, you know.
So I was watching Spanish, but Okay, so. It's asking us to. So we have our data sets right here. And it's asking us to create a table which we'll do in Excel. To include frequency, cumulative frequency, apparent limits, real limits, midpoint, frequency times midpoint, midpoint squared, frequency times midpoint, squared percentage, cumulative percentage, rounded percentage, and cumulative rounded percentage, and then the nursing student data. So the College Board scores. We have the apparent limits. So let's start with just going into Excel, and we're gonna put these apparent limits in a column. That's all we're gonna do. We'll do that as a group, okay? So we're gonna do file
Should we open this, assignment?
or Excel. Excel is probably the easiest way. Yeah, open the assignment so you can refer to it. So it wants us to create a table
Is it in class activity?
in class activities, infographic, assignment 3 and 4. Does everyone see that?
Yes.
Okay. So I'm just going to, so I'm gonna say, should I make that bigger? Should I zoom in?
Is it in chapter 4?
No, in class assignment, in class activities, infographic, and then right below infographic. I don't think I can zoom in anymore. So I'm gonna type, they want a table. So we're gonna create a table, apparent
Oh,
limits. Now we might be able to cut and paste, maybe. No, maybe not. Okay, so let's just list them. So apparent limits, we have 750 to 799. So everyone know where I'm getting this from? I'm just typing it in. 700 to 749. $650 to $699. 600 to,
PSS score to go, right?
not for this. 500 to 599. No, 550. 550 to 599.
550 to 599?
Mm-hmm. 500. These, yeah, to 549. I'm getting these, Jackie, from. I'm literally moving these numbers right here from the in-class assignment. That's where I'm getting those from. It says create. So our directions are create a table to include this, to include frequency, cumulative frequency, apparent limits, real limits, midpoint, frequency times. So I'm starting with the parent limits because they gave those to us. We're going to do all of them, but it's just easier to start with the parent limits because we have those. 500 to 509.
What if you do not have Excel?
You have Google Sheets.
You have Google Sheets,
Okay, nice.
and you have a computer you can log into with Excel. I think you get it free from New Page, though, don't
Yeah,
you?
you do. You do get it free.
49, 400 to 449. 350 to 399. 300 to 349. 250 to 299. 200 to 249. So all I did is I literally took that information under apparent limits off of that sheet. I put it in Excel. Everybody with me so far?
Yes.
Okay, so the next thing it asks us to do is it asks us to. So it also has to include frequency, which we have, so we can do that pretty easily. This is frequency right here. It's those numbers right there.
And you want to place those numbers next to it?
Yeah, we can do that, yeah. Frequency. So we're gonna do frequency and we'll do 9, 27, 29, 32, 35, 69, 58, 45, 36, 19, 8, and 4. So all we're saying is the number of times we're hitting these apparent limits is this number of times. That's it. And we can say frequency or F. Then you can also move it if you'd like. You can just go insert. And maybe give it like 3 columns.
Let's say like,
So all I did was move that over. I just moved frequency over and I gave myself a couple columns to see why in a moment. You just right click the column and then you click insert. Or you can right click the column, the whole column, and you can go delete. And maybe give yourself 1, 2, maybe give yourself 3 more rows. So all we've done, we're creating a table. All we've done at this point is move apparent limits and frequency from the Word document into Excel. That is it.
What if like I just put the number and I forgot to type the current limits?
So all you gotta do is just highlight number 1 and then right click and then go insert and it'll give you another thing and it'll move them all down.
Wait, 1 second.
How do I delete one? I have like, I don't know, I messed up.
Oh my god.
How do you like,
Oh my god.
how do you like?
Oh, you haven't even seen the card trick yet.
How do you like delete?
I have a card trick coming up when we get the probability to prove how cool math is. That's for chapter 5.
It's kind of is like.
Everything all right back there, Jackie?
Yeah.
Holding the lip? You're okay? All right.
Because I get this.
Okay, cool.
So I got half.
Okay, awesome. So that's all we're doing. So the next thing,
Wait, please, just please 1 second.
what do they want?
I'm still typing.
Frequency, apparent. So
Bless you.
Bless you.
So just apparent limits and frequency, and then I would probably throw some columns in there, about 3 of them.
Whoa, whoa,
Please, please.
what'd you do? What'd you do?
Wait, there's 13 rows. Okay, yeah.
Bless you. How'd you do that?
Real limits, range, and real. All I'm doing is I just added 3 more columns. Real limits, range, and real range. And the reason I added those is because in the Word document, it's asking us for the real limits. Oh, and I want to show you the range. So for the real limits,
We're gonna worry about the,
we're gonna do this all of this stuff.
midpoint of that.
We're gonna do that. Or if you want, you can do this. You just type in frequency and then we can do cumulative frequency. Cumulative frequency. All I'm saying is like we can put the labels in right now. And then you just make this bigger if you want, like that. And then we're gonna have the midpoint. I'm literally getting these off the Word document. That's not just pulling these out of the air. I'm gonna blow your mind when you see that card trick. I'm telling you.
Wait, hold up. My since cumulative frequency is a long word, it's going into the G thing.
Watch frequency times midpoint. Same problem that you're having. Look at that H. That's a problem.
Oh my god.
And then I'm just gonna make that bigger. Okay, frequency times midpoint. What was it? Midpoint squared. Yeah, then we'll do midpoint squared. Midpoint squared. You just take your mouse
I got it.
and then move that over. And then what else? What else did it ask us? It asked us, I think it's frequency times midpoint. All right. Frequency times midpoint. No. Oh, wait. Frequency times midpoint squared. Frequency times midpoint squared. Those are from the Word document. So now I'm gonna make this a little bit bigger. So we're gonna work in Excel. It's squared, that's fine. And then we're gonna do percentage. CNTAGE. Percentage, yep. And then we'll do rounded percentage, I think it is,
Wait, why are we doing this, all this stuff?
because it's review of chapters 2, 3, and 4. And so you know how to work with the numbers. And it's the assignment. And it's 2-page curriculum. And it's a stats course.
We don't need it.
And I'm the professor, so whatever I say goes. Like, what other information do you want?
So do we need to follow the curriculum? Do we need to?
Well, I'd like to stay employed, so yeah. Cumulative percentage.
It keeps overlapping, how do I?
Just keep making it bigger. Just take and
I double click it.
just left mouse click and then move that over. Cumulative percentage. And then we have the cumulative rounded percentage, and that should be the last one. Yep. Cumulative rounded percentage.
Hold on.
Okay.
And that should be the list of everything. And I think I might have added one or two because like the range and the real limits are important.
Can you move to the right of it?
Right? Sure.
Yeah. Okay. Round percentage.
So we're gonna have all the labels. If you do them in that order, it'll be probably easier. They don't have to be in that order, but it'll probably be easier if you give all the, just right here is where you need it, IFA.
Yeah, I finished it.
Okay, all right, so real limits. So the real limits, remember the 0.5 above and below? So our first one, 19 would be, so 200 to 249, what do you think the real limits would be? 0.5 below, 0.5 above, that range, what would that look like?
195.5.
199.5 to,
249.5.
yeah, that's it, 249.5. So then our next one would be 249.5 to 299.5. Does everyone see where we're getting that from?
Not the 0.5.
The 0.5, so that's, so we have the real range. So the real limits are the highs and the lows of the 0.5 above and below the apparent limits.
Okay.
Make sense? Just saying it like that. Gentlemen in the back, is all making sense? Because you guys are generally pretty quiet. Okay, cool. All right. Which is fine. I just want to make sure I'm not losing anybody. So 299.5 to 349.5.
And the one on top would be 299.5.
Hold on.
Yep. So those are our real limits. These are our apparent limits. And we literally just went 0.5 below to 0.5 above, all the way up to the top. So apparent limits, real limits. Then we do the range and the real range. Does anyone remember what the formula is for the range? Bring it home.
It's just the upper limit minus
Or lowest number minus the highest number, or highest number minus the smallest, yeah. So what do you think the range is for the first one?
upper limit.
Yeah. What about the next one?
Somewhere around 40.
Yeah. They're all 49. Does that make sense, everybody?
No.
Wait, I was finishing this, can you? repeat
So
it?
the range. The range is always highest minus smallest number, or lowest or largest minus smallest number.
So. just-
So 249 minus 200 is 49. 299 minus 250 is 49.
All 49 across the board.
So they're 49 across the board for the range for each one of those. So if you want to be fancy, you could, of course, just grab this and just go fill up.
Oh my god.
I just blew your mind. Wait for the card trick.
Okay, wait, how do I do that on, the spreadsheet for?
I
Google?
think I'm joking. There's a card trick coming up
Wait, what should
later.
we do?
So if you know that it's all 49, you can just take this, left click with your mouse, drag all the way to the top, go over here, click fill, and click up. I just blew your mind.
Well, and dude, not even that, the animation where they like all fill up, dude. It's
Hmm.
satisfying.
It's like the transitions for your Google Slides.
Yeah, yeah, very satisfying.
So that makes sense, right?
Yeah, I'm just trying to find the fill. I mean, I already did it, but I just. Right under the outer. Oh, okay, thank you. Yeah, I'm good now.
So everyone knows why it's 49, right?
Indeed. Wait, so for real range, for.
What's the real range? Yeah, keep talking. Yeah.
239 and 250, right? Wait, no, it's -1, so it's,
No, the real range is always one more, remember?
yeah, so it's 50
Yeah.
across the board.
So the real range is gonna be 50, because the 0.5, and that also has to do with your real limits, because if you take 249.5 minus 199.5, you're gonna get 50.
Okay,
Real limits, real range. See how they're related?
how do I copy the thing you did for, Google spreadsheet?
Or you type, or you can do 50, and then you can go like this,
Yeah, how do I
and
do
then you can
that?
go fill.
No, but for my thing, you have Microsoft. I have Google spreadsheet. How do you
I don't know
that?
if Google Spreadsheet has that feature. And then I click fill down.
You gotta pay for it.
Does that all make, so apparent limits, real limits, range, lowest, largest minus smallest, real range, that's at 0.5. But if you look at you see how like if we took the real limits and subtracted them from each other, we would get the real range.
Is that the formula? For if you wanna find real range, you could also do real limits.
It's, yeah,
subtracted?
yeah, because we're accounting for the one more because of the 0.5 on to the left and the right, at the top and the bottom. And then we have the frequency that we've already done. So our next thing is our cumulative frequency. So when we do cumulative frequency, we're adding the frequencies together. So our first one, of course, is 4. So then we're going to say equals
Wait, what?
the frequency, cumulative frequency. So we're going to go,
Oh.
we're going to accumulate towards the top. So 4,
Quick question.
yeah.
Why are we working backwards? Or do we just put the numbers in that order?
We just put the numbers in that order. I mean, technically,
The 200 should have been on the number 2 line, right?
we can go from the bottom up or the top down.
Oh, it doesn't
Like,
matter.
it's a cumulative frequency. So the way I'm doing it is going from the bottom to the top. But technically, you could
Either or.
do either or because it's a cumulative frequency.
I thought you were just looking for a reason. Or just because
And well, also numerically too, because these were the smaller numbers moving towards the top. So I'm starting with the frequency moving towards the top, like it just, that makes sense. So 4. So this one's 12. Does anyone know why that's 4 and then 12?
And then 12 plus 19.
4 plus 8. So this one would be equals F12
Oh, yeah.
plus E11, right? No,
No, that's false.
I don't think that's a number.
31. Is that right? 19? No, it's
31 plus
no.
36, right?
I don't think I wrote the frequency right there. Right? No, that's right. 31. Yeah, that's right.
Oh.
30,
Wait, how do you get the 31?
12,
Plus 19.
19.
Oh.
So then our next one would be 67.
So if you
45.
31.
That's
36. Yep.
Last number, oh,
Plus 45. So our next one is 112.
And then 170.
Yep. And then 170. Someone tell me the next number.
239.
Yep.
34.
Yep.
306.
Yeah, that's right.
335.
Yep.
I just. No, not with the map. With my type.
Yep. 362. And what's our last one? 371 is right. Yep.
Wait, why did we start from the bottom? Could we have done-
Well, no, because these started from the bottom. These all went up to the top. So we're following that.
I have a question. It's not really related to the numbers, but why are like columns A and B from left to right, but columns C through F are right to left? Not right to left, but it's like moved over. So instead
What do
of
you
being
mean?
like on this side, it's on the other side of the.
You mean like this?
Yeah, like why?
Oh,
why-
that's just the setting.
Oh, okay. I was just wondering what, no, I meant like, why is 49 on the others, on that side instead of on the left side of the, like,
Oh, it's just the setting.
oh, okay.
I can
I
play
thought
with-
maybe there was a reason because like the first two columns are,
No, I could take all these if I want and I could just like center them
oh,
or
okay.
like, is that better? Is that in your brain make more sense if they're centered? It's okay if it
Yeah,
does.
it does actually.
Okay, so all you do is if you want to center, you just you could literally take all of it, or you could be fancy and click the whole thing and then just click the center button.
Ooh, okay, thank you.
Click the little arrow right here on the top left-hand corner and then
Thank you.
click
Thanks.
that, and now they're all.
Makes it easier for me to read.
Oh, wait.
I don't know
Yeah.
why. Don't know the logic behind that. but-
Wait, now for the midpoint, you just do the numbers, cumulative frequency divided by 2.
So what would the midpoint be?
Is that what it is though?
So the midpoint, the range is 50, right?
Oh, 25.
That's right.
So it's all 25?
Not quite. What do we do with the 25? What do we add it to? We add it to the bottom real limit to get the midpoint. So you'd have 224.5.
Hold on. Wait.
Because remember the midpoint's halfway through, so the range is 50 between the numbers, and then we have to add it to the bottom number of our real range. So you get 224.5. So all I'm doing is I'm saying my range is 50. But my midpoint is going to be the range divided by 2. So the 25, but I have to add that to the lower real limit,
Oh, okay.
which is 199.5, which equals 224.5. Does that make? So what's our next one? Yeah, 274.5. So we have 224.5, 274.5. So want to try to tell me the next one?
So you use that same equation, our numbers on A.
Yeah. Oh, well, on B.
324.5, right?
Yeah, 324.5. Yep, that's right.
399.5?
No.
Sorry, 374.5.
374.5 is right. Yep.
424.5, I believe.
Yep, that's right.
474.5. 524.5. 599.5. Wait, yeah.
Hmm,
Wait, no, yes.
no, 574. Yeah. 574.5.
Hold on.
Yeah, that's right. 624.5. So all I'm doing is I'm adding half of the range to the smallest, to the lower real limit for each one of these. So if I take 50 plus that, I'm gonna get this all the way up to the top. So we're adding to the real lower limit to get the midpoint, because we're taking half of the range to get to the midpoint between where the numbers are. So this would be 6. This is, yeah.
Yeah, I think the one below is wrong. Believe.
Wait, we're adding 25, not 50, right?
We're adding 25.
Yeah.
Yeah. Yeah, 424.5. Oh, yeah. I skipped one. You're right. Yeah. 474.5, 524.5. This is 574.5. Yeah, I skipped one. This is 624.5. This is 674.5. This is, yep, 724.5. 724.5. Yep. So our next one is frequency times midpoint. Does everybody have those before we do the next thing?
Wait, no. Frequency times midpoint. Oh my god. So now you do 9 times 774.5.
Yeah. Or if you want to be fancy, you can say equals E2 times G2.
Times. Oh,
Frequency times midpoint.
6. Yep, that's right.
wow. That.
Dude, oh my.
Yeah, that actually worked. Cool.
Wait, for the frequency time.
Why'd you erase it?
So what's the next one?
We're not gonna work from bottom up.
Start from the top down.
Oh my.
Yeah. So you should have 19,561. We can do it either way. It doesn't matter. You go top. We're just multiplying left to right. So it doesn't matter. We can start at the bottom of the top. We're not accumulating them in terms of the order they are. We're just multiplying them. So if it makes more sense to y'all, we could do it this way. We could say equals what is it? E13 times G13. We can do it that way too. Same thing. Or you want to see the actual map?
Probably the actual.
Okay. So equals frequency, so that's column E, so that's E11 times midpoint, so that's G11.
Times the lowest bar, right?
Yeah, so I don't know if you can see that, but I haven't hit enter yet. So I have frequency times midpoint,
Oh,
but I'm using the cells to reference it because it's column and rows.
yeah,
So this would of course be equals E10 times G10. That makes sense, frequency times midpoint, left to right. Hit enter. That. So this would be the same thing, equals, right? It's 10, yeah, so this would be equals E9 times G9. Yeah, frequency times midpoint, that makes sense. Ooh, what did I do wrong? Oh, I did it to the power. I screwed that up. That's times. Well, it's silent. Mine's on silent too. I'm glad you're here. No worries. All right, so E8 times G8, frequency times midpoint. Equals E7 times G7 equals E6 times G6 equals E5 times G5 and equals E4 times G4. And is that right? Those are right. That makes sense? Is it all?
because after a while,
Yeah. Or you can do fill up or fill down. But the fill up and fill down does not always work. The trick is to put a dollar sign in there when it doesn't work between the letter and the number of the row and the column. Are you guys ready for midpoint squared? Are you still doing frequency times midpoint?
No, I just want to find where you can square on the call calculator.
Oh, frequency times midpoint squared. And then we'll do percentage, rounded percentage, and cumulative rounded percentage. So you guys want to work from top to bottom or bottom to top? It doesn't matter for the next one. Top to bottom. So midpoint squared, we have our midpoint. So that would be G2 to the second power like that. It's shift 6 to the second power. And there's your number. That's right. So then it would be equals G3 to the second power. Same thing. Equals G4 to second power equals G5 second power equals G4 second power equals G3 equals G2.
there's also an autofill button.
Yeah, or you can go like this and you can just go fill down.
Oh my,
Wait, and
this guy.
Yeah,
See all that.
yeah, you can fill down and fill up. But you want to be careful because sometimes it doesn't work. And the trick is to put a dollar sign between the letter and the number in Excel if it does something wonky. Yeah, yeah. And then enter. Let me see what you're doing. G2. No, you did it backwards. Oh yeah, no, you're right. No, you're fine. G2, and then you gotta add 2. There you go. Yeah, that's all it is. Oh, then it filled down wrong. Then it filled down wrong.
On mine?
No, on mine.
Oh,
That's why. So you filled on, that's an example of filled on not working. So if I go like this, I put a $sign, and then I take this and I fill down. Ooh, not quite. That is, we're gonna have to, I don't think that's gonna work. That work on, that one does not do the autofill. Was G,
Oh.
oh, hang on, it might be this. This might do it. Equals,
I think it's around, it's still on Google.
no. Equals. Equals G 2, the second power. That's right. And then if I fill down, does that work? Fill. That's fine. Yeah. It was a fill down thing that wasn't working. But if I check these, if I look at like up here, they all make sense.
Yeah, they do.
So that's how we know that works. So then frequency times midpoint squared. Are you guys ready for that? Are you still? No, no problem. Pretty similar. I'm gonna wait for everybody to catch up and then I'll show you. Yeah, it would be
Numbers are confused, why?
so that you're comfortable working with big numbers. Waiting for everybody to catch up before you do it. Just tell me as you good? Okay. So frequency times midpoint squared. Well, we already have frequency times midpoint. So all we gotta do is square it. So we just go equals H2, like you said, Jackie, the second power. Bam. This would be
Wait, I got something else.
H3 to the second power.
But what I did was I literally did midpoint times what we got in the column for midpoint squared.
Which one is it? Wouldn't it be? You can see.
Oh, I did that wrong. Yep, you're right. You're right. Yep.
It's G-
Frequency, so that should be equals
G
E2
column times I column, right?
frequency. Yeah, but frequency times midpoint. It should be H2 frequency times midpoint squared. So that would be equals H. Yeah, equals H2 frequency times midpoint to the second power. Because we already have that.
I did so E column times I column.
No. Don't, that's just gonna make it complicated. What did you do?
If you do, if you do, E,
That should work in theory. You're saying E2 times G2. We're gonna have to do brackets for that to work. We're gonna have to say
no, times I.
frequency times midpoint squared, so it'd have to be equals E2 times G2, right? Times
No, I.
times I.
Yeah.
Frequency times midpoint squared. Oh, that should work in theory. Should be equals E2. That's like extra steps in the math, though. Equals frequency E2
I.
times midpoint squared, I2, right? E2 times frequency times midpoint squared. Yeah. But see, I think it'd be way easier if you, just did. We already have frequency times midpoint. Why don't we just square that? That would be way simpler. Eight equals H2 to the second power. Just square that because we already have it. The other way is like adding extra steps. And the problem, it's not that can't work in terms of math, but you start getting into PEMDAS, order of operations, where you have to be very specific about what you're doing with your numerator and denominator and having lots of brackets so that Excel doesn't do it wrong. But if you just take what you already have that you know, we already have the frequency times midpoint, so we just square these, that would do that. Does that make sense, everybody? As to why it's an easier way to go about it. So equals frequency times midpoint equals, yeah, H3 to the second power. Second power.
We just square the whole H column.
Mm-hmm. Should look like that. But I know it's right because if I look, you see the formulas keep matching. That's how you know fill down works. So all I did is I took this column and I squared it because it's frequency times midpoint squared. Period. Makes sense? Should I walk through that again? Okay. Okay. So then our percentage yeah. So for the percentage, what we're doing, I was just checking my math, make sure I explained it to you right. So you see our frequency and our cumulative frequency column. So we're gonna take 4 into 372. 371. 371. Because it's a proportion.
I'm sorry. can you go
Yeah, so the frequency, we're gonna take this number into this number because the percentage is a proportion.
divided?
So the total N, the total number of things that are happening are 371 times the frequency. So we're gonna take the frequency of the thing hitting and get a percentage. Now I'm just doing decimals. Now, obviously, if you move it, you multiply it by 100, you move it over 2 places, that would actually be your percentage, which would be like 1%, 1.07%.
So are they all gonna be divided by that,
Percentage, yeah.
the 371?
Yeah, so this would be 8 divided by 371. Nope. Don't do that. So I'll do it by hand. Equals E12, that one right there, divided by F2. Can-
Divided by F2, right?
Yeah, but can you see why? Because if I was highlighting that, it's a proportion. So we're saying what is a percentage against the total amount? Equals E11 divided by F2.
Wait, what's the dividing symbol? Just so we know.
Equals E10 divided by F2, like that. Like the slash mark.
I'm getting the number on the back.
So I'm taking
Wait, what are we doing?
this or this or this divided into the total frequency. So it's a proportion, like the number of times thing happens is on the numerator against the total number of times thing happening, and that's how you get the percentage.
But I put it in on the bottom, for column 13, I did. Or E13 divided by,
Yep. And these are basically percentages in decimals right now. If you like,
You couldn't do this in the filter.
no, maybe, let's find out, equals E9 divided by F. No, you can't do the fill thing. It does not really work. So this would be equals E8 divided by F2. And everyone understands why we're using the letters and numbers, right? We're just referencing the columns against the numbers. That's all it is.
I don't understand how what we're doing right now to find the percent.
We're taking the frequency because it's a proportion. So 69 times in those limits that thing was hitting against the total number of the frequency. So like
Divided by the, so wait, frequency divided by what?
the cumulative frequency, the accumulation of all the frequencies.
Oh.
It's kind of like N or your population.
I have a question.
Yeah,
My last digits are not actually yours.
I do it right. E8,
The one's like the whole number is like, right, but then they added like 2. Like it'll be 7, 1, and then 1, 6 for the last one, and then it'll be 4, 2, 3, 2. Like it just extended more.
oh, that's this. That's the setting. If you go right here, and you can go like this.
Does it really matter?
How would that work?
Can you zoom in?
What this should let me. Oh, it's not. Maybe we'll just do it here.
I tried
See?
to.
What I'm doing there. I'm changing the number of decimals. That could be why. Like this one needs one more. So obviously this would be like 15%. I'm just showing you in the decimal form. Does that make sense? If I multiply it by 100, it wouldn't look like a decimal. For what I'm showing you next,
Or do you just want to keep these numbers in the percentage?
keep those in the percentage column for now. The reason I'm saying keep them in there is because when you start trying to do percentages, Excel wants to round for you. And I'm going to show you how to round in a moment. That's why. Yeah.
To be clear.
So like I don't want 15.6%. I don't want to say 16%. That's why I'm keeping it in decimals.
Frequency divided by.
Sure, so I don't have to write all
E7 divided by F2.
Is that what we're doing? Frequency divided by cumulative.
Yeah, frequency of a cumulative frequency equals E6 divided by F2. Yep. Equals equals E5 divided by F2 equals E4 divided by F2 equals E3 divided by F2 equals E2 divided by F2. And those are percentages. We can move the decimals to the left or right by using that, no, that right there. That, like that. And everybody understands that if I move it over to, if I move the decimal point, if I multiply any of these by 100, it would move the decimal point over 2 points, and then I would list it like, for example, this one right here would end up being 0.097. So I multiply by 100, I'd have 9.7%. I'm not listing them that way because Excel is going to want to round them. And we're going to round in a moment.
Wait. I didn't have to do one.
So see like 0.121. So like, do you see that one, Jackie? So 0.121.
Yes.
So if I multiply by 100, I would get, so I had 12.1%. I'm just leaving these in decimal form just for
Right now.
and convenience.
There is a percentage on top,
And it's gonna round for us if we do it.
so it doesn't work.
It does work. Yeah, if we could literally, we could take these and we could just go like that and it'll do it, but I don't want it to do that.
You want them to figure it out.
Well, because it'll round.
And you don't want it to round.
I don't want it to round because I'm gonna do round a percentage right now.
Oh, no, I'm saying, can we do that for the L?
No, because I'm gonna explain it to you.
Okay.
I'm gonna explain it by hand. Then you could, but I don't want you to just hit it because then you don't understand like
Yeah.
how you're getting there.
Yeah.
So the rule with rounding is it's to the right of the decimal. 0.5 and above, you round up. 0.4 or lower, you round down. So this one is going to be 1%. Does that make sense? Okay, so we have 0.
Are you saying
Point.
it's 1% because that's the lowest you could possibly put?
No, 0.017816671. So to get a percentage, I multiply it by 100. That moves this over 2. So now I have 1.07%.
So in that case, when we round up.
Well, if we're trying to get just to like an integer, the 7 would say you have to round this number up right here. So it'd be 1.1. A 1, we're going to round down, so it'd be 1.0%, and we don't have to necessarily write the 0.0. Make sense?
I don't know. Like we keep going until.
In a general sense, I'm going to say that
How do
like-
you want to- if you want us to write the 1.07 or the 1.0?
I would want you to do this work. I just want you to do like tenths or hundreds.
Okay,
And if I do that, and then it makes it much more clear, doesn't it?
yeah.
So-
Can we do that on ours too?
Yeah, that's fine. So this is 2, this would be 2%. Now I would probably, because we're rounding, I'd probably would take these and I would make them 3 just so we can practice rounding. Okay,
The, non-rounded.
so this would be 5.1%, right? Or 5%. 9.7%, what are we gonna do? The 10%, yep. 10%. 12.1%. 12%, yep. 15.6. 16%. 18.6. 19%, yep. 9.4%. 10%. Not, no, 9.4, so 9. 9%, right? 8.6%. 9%. 7.8%. 8%. 7.3%. 7%. And 2.4%. 2%. So all we do is round them based on what they were to the thousandth place. Everyone get a sense of how we got there? All right, so now we have the cumulative percentage. So this is where you have to deal with just like the rules of math. So we can agree this is 1%. We can agree that's 3%, right? Cumulative rounded percentage. No, cumulative, no. Cumulative percentage, not rounded. Cumulative percentage.
Oh.
Cumulative percentage. So what we would do, we're not doing rounded yet. So what we would do is we would take, this would be equal to, so the first one would just be equal to K13. It would just be that, okay? But then this one would be equal to K13 plus K12. But the problem is the percentage thing is on, and it's trying to round for us. I don't want percentage. I just want decimals. No, not general. Okay. Like that. And then I can take, and I can make these all.
How'd you? Oh, wait.
Like that,
Shoot.
because that makes a little more sense. So this is going to be equal to K12 plus K11. Equal to percentage. So K13 plus K12, K12 plus K11.
Professor, how'd you get it to the decimals again?
Oh, to change that, I just highlighted the whole thing, and then I moved this to, or that, like that.
Oh, here's like no.
All right. 0.5.
Click like the left decimal.
Yeah. Could be your version.
I'm mixed up.
Do you highlight the whole thing?
What are we adding exactly?
So all we're doing is we're taking these percentages and we're adding them to each other, and we're doing a cumulative percentage,
Okay, so
which we should end up getting up to 100% basically at the top. So this should be equal K11 plus K10, because we're adding those. So now we're at 14%. That makes sense,
it works.
right? 14. That's not okay. Equals K10 plus K9. 21 equals K9 plus K8. Yep, equals K8 plus K7 equals K7 plus K6. No, I did that wrong. No, something's not. Doesn't make sense. K8 plus K7. 7. 6. Should be a higher number. No, that's not right. Oh, okay, so K13 plus 12, and then it would be, this would be equal to M12 plus K10.
Okay, now.
Yeah, now that makes sense. 1, 3. No, that's not right. No, that's not right. Equals,
So it's gonna be like K, good. Where did it be K11 minus K? And
It'd be-
K12 minus, or plus
would be
12 and 11.
K, it should be. No, because it's a percentage, so it would be, the new number would be, it would be equals M12, because that's the new one, plus the new one, which is K, which is K10. Yeah, so that it goes up. Should be right. 3% plus 5%. Doing wrong with the formulas. That would be the same. K13 plus K12. That would be right. So this should be. Yeah, it should be equals M12, that one, plus, because it's cumulative, plus,
Isn't it easier if you work from line 2 down?
what do you mean?
Isn't it easier if you work from line 2 down?
There we go. That's right. Now it's working. So this one plus that one, that's about 8%. That's right. So we're gonna say equals, yes, it's the same thing all the way up. If it'll let me fill up. Yeah. That's right.
Oh, mine is not doing this.
So what we're doing is we're adding, so we got our 1%, then we got our 2%, so that's 3. We got plus 5% is about 8, plus 10 is about 18. So I'm adding each percentage all the way to the top to get to 1.0 or 100%.
Oh,
Wait,
this is not.
did we do it wrong before?
No, we've done it right.
I had,
So this is, so what I did is I did, first I said is equal to K13, because I'm just moving that over. Then I said K13 plus K12. So that's this one plus this one to get this number. Then I said equals M12, which is this number, plus K11, this number. So then I did the same thing here, M11 plus this number all the way up.
Why for line 12 you added the K, the 2 Ks, and then for the rest you added the KM? Wouldn't it be
Technically, that would still work.
M13?
You could still do that. It would still be right. If you said M13, it'd still be correct. So we can say this equal to K13, it's just the same. And then equals M13 plus K12 equals M12 plus K11 equals M11 plus K10. Does that make sense? Do you want me to, like, if I actually click on it, you can see it.
Oh, you're
Okay,
doing
the
that,
100
you're doing that and stuff.
So I'm basically taking each percentage and adding it to itself at the decimal level to get up to 100% at the top. So that's why, like, this is like right here is about 30%. But if you eyeball that, 12, that's 22, that's 7, that's 29, that's 20, like, then we're dealing with decimals. So that's technically 30.2%.
Is it okay for like not exact on this stuff?
This should be pretty exact because we're not rounding it. We're just doing the cumulative percentage.
Well, I think it just only shows like 0.01, 0.03.
Oh, you just have maybe one less decimal or something.
Oh, yeah,
That's probably all it is. Because if you highlight this and then you play with this, you can change that. I was going 3 places to keep it easy.
Starting to match up.
So if I click this, right, that one's MK plus K, which makes sense because I'm literally just adding each one of these percentages to each other all the way to the top to get to 100%. Because that's a cumulative percentage. Do you want me to go step by step? Or do you guys need a break? How's everybody doing? Some of you I think are getting it, some of you are like looking at me like deer in the headlights. So talk to me like, so I'm taking this number and I'm adding it to that number. I'm adding this. So first I'm just moving this number over here. Then,
Don't know, will always be like that.
and then I'm taking this answer that I have and I'm adding it to the first percentage. And then the next one, I'm taking the new answer and I'm adding to the next percentage. And then this one, I'm adding to that percentage. And then this one, I'm adding to that percentage. All the way up. And because we're dealing with non-rounded decimals, well, that's why we end up at exactly 100. We're gonna have a problem in a moment with the rounding, but I'm gonna show you what the rule is to deal with that. So like this one was this number, because it's cumulative, plus this next one to get to that one. And then of course, the last one is this number plus that number to take us right up to 100%. Because you can't exceed 100% because it's a proportion. It's the number of times the thing happens with the frequency all the way up to the maximum amount of frequencies. Yes.
So it's just one of my columns. It's like 12 keeps trying to put it into a percentage and I don't know how to change it and keep trying to change it. It won't.
Oh, so what you do is highlight the whole thing, click on number over here and click on,
Wait, where did
I can do that. So just highlight your column except for the words and then click on number right here. Or you can click, yeah. Or you can click here and just tell it number.
Okay.
And then it'll do that.
Okay, thank you.
Yep.
It was just like one column and it was so annoying.
So everybody ready for cumulative rounded percentage, or do you still want to see cumulative percentage?
So if you want to do one.
Okay, no problem.
2, 3.
Yeah, that's fine. Yeah. 2 places is fine. 3 is fine. When you're in like a test environment, I would say 1 or 2 places. For the sake of like the assignment, I'll take 2 or 3 places. I would probably take 10 places, but like 2 or 3 is really all you need.
But in a test, go for 2.
Yeah, 1 or 2. If you know how to round, because like if the test gives you like if it's multiple choice, it's gonna either say 1 or 2 places from the decimal in the test. Do you guys want to see the formulas? Would that help? So I just moved this number over here, and then I just started basically adding this to that, to that, to that, to that, to that, all the way up. But I did it with formulas to reference the previous number. I feel like some of you are like, makes sense. Some of you are like, I don't like the formula or something. Or is it all making sense? So you ready for cumulative rounded percentage?
Yeah.
Or anybody totally lost? Okay, so cumulative, so we already have the rounded percentage. This is actually pretty easy, but we're gonna encounter a problem. So let's say, so we can agree that the first one, of course, is gonna be equal to L13, right? It's 1%. That makes sense? So then we can agree the next one is gonna be equals N13 plus L12. I'm taking the 1% adding, I should get 3%. Yeah,
But for some reason, I'm every time I put in the decimals, and I press enter or return, it like changes it to the percentage, like.
oh, so just highlight right here, just highlight your whole column. Click on the little number button right here. And then click number. And then click OK, I'll get rid of the percentage problem.
So do you want the, do you want N in percentages or in?
I do,
Okay.
so that we have a problem. Like I want us to have a problem as we approach 100. Because we're rounding up. And as we round, we're gonna exceed 100%. You can't do that. I'm gonna show you how we address that. So this is equal to, I mean, pretty simply, it's equal to 8%. But if you want to do the formula, you can say equals N12 plus L11. You should get 8%. This is equal to N11 plus L10. Right? And can I fill up? Will it even work? Yeah. Or you can also just do fill up like that and it'll do it for you. Once the formula is in there.
Oh, you gotta go.
Oh, that didn't work. Not do what I wanted it to do. So that happens to come out really nice, but let's just say for the sake of argument,
Are we done with this whole thing now? This whole graph?
I gotta teach you one thing and then we're done.
No, like this specific,
Let's just say this was 99%. And now we have a problem. Because now we have over 100%. So let's just say you're rounding and then you get to the last number. So how you deal with that is you round the last one down. So you just round it back down to 100%.
Oh, so that's why
This was actually 98, but my point is like, if you're rounding, then you get to, and you start to, and then you get to the cumulative one, doesn't make sense, or you're over 100%, you round the last one down.
But that one wouldn't be 99?
It is technically, it is 98, but I'm just saying if it was 99 and then I had 2% in, I can't do this.
Yeah. No, I
So
get that.
what you deal, how you deal with that is the very last number, you round it so it makes sense.
Okay.
For cumulative. Because you're not gonna exceed 100%. And then that is the first half of the assignment.
So is that other one supposed to be 99%?
No, it happens to be 98. I'm just trying to, for the point of teaching it to you.
Okay.
Our rounding happened to work this time.
So if it were 99, you would have to change it to 98?
Yeah. You round, yeah, that's right. You round the one right before the last one, so you get to 100%. It's like math, it's like a Band-Aid, like you gotta like rip it off fast.
Isn't 9-4 supposed to be 9-4?
What? Is it? 91.
I got 91.
Oh.
Yeah. So in this case, it's fine, but like I said, if you keep rounding you basically round that second to that last one so that it makes sense for a cumulative rounding so that you get to 100%. You can't exceed 100%. So we just did all this stuff right here. We just killed it. Now we got nursing data.
Oh my god.
Oh my god.
Dude,
Oh my god.
what is up with this?
Simple frequency distribution, graph data. It's pretty easy. Yeah. Guys want a break? How's everybody doing?
I'm down.
Got about
Wait, how long would this take? This thing right here.
about an hour. Might take about an hour. We're gonna take these grades and we're gonna put them into Excel like that.
Wait, so we're making a new Excel file?
In the Excel file, but you can cut and paste them into Excel. Then we're going to create a frequency distribution table. I think that's what it says, right? Frequency distribution. Say.
Try. copy, paste.
Simple frequency distribution and graph the data. Yeah.
Yeah, let's take a break. I'll break.
Want a break?
I did it
Yeah.
in-
All you do is highlight it, Control C, open Excel, Control V, and then just make your columns bigger, and then you got all your data right there. Just do that, and then I'll show you how to do this, the frequency distribution.
Oh,
Of course, it doesn't work for the spreadsheet. Of course it doesn't.
Just yeah, take like 5. It's fine. This part's easy. This might only take like 15 or 20 minutes, and then we're done with chapter 4, and then
It just says it's gonna take an hour.
it might not, because I know some Excel tricks.
Dude, okay, if it's gonna take 15 minutes, and
No, it's fine. We'll take you guys. How, if everybody needs a break, we'll take a break. 5 minutes or so. Does that work for everybody? 5. Okay. So it's come back at like 8:52. Yeah. So yes, but not yet because we haven't done all the steps. So we're gonna do a simple frequency distribution table, which is gonna be basically be like a list of the value, which is X, and the number of times that it occurs. Now you can count it, but that's so like 2010. So I'm gonna make Excel count for us. And it's gonna be way faster. And then the other thing, I think that's SPSS. And that's literally just bringing the data in, I'm pretty sure. That is. Measures Essential. Yeah, that's actually really easy. So
I'm on the site.
Oh, that's easy. So all you do is you just take the numbers, highlight them with your mouse, left click, Control C, get a new Excel document, and then just do Control V, and then they're gonna look like crap, and then they're just gonna make the columns wider, and you'll see them.
Really started already?
No, she's asking a question. We're not sure already. That's not really even a problem. I mean, I'll look, but that's not necessarily a problem. Your columns wider. Oh. Or you can type them, I can call them out or something. If that would be helpful. Yep. Always. I don't know if I'm always screen sharing because that's hard, but I could probably screen share on the other.
Yeah, I just.
That's okay. That's totally okay. And it's on YouTube, right? This exact recording says, it literally says assignments 3 and 4, and I'm explaining all of this already. You could literally like get the notes or take an app, even before it's posted, because it's literally on the YouTube channel, assignments 3 and 4 are part of the keyword just all over the place. Thank you. Ready for simple frequency distribution? All right, so if you had trouble cutting and pasting, I'll just read the numbers to you. You guys ready? 72. 68. 81. 58. 65. 70. 83. Or I can just make it giant. Like I can just like zoom way in. Might be a little too far. So 83, 74, 58, 36. Did that so far, everybody? 49, 73, 60, 59, 60, 93, 32, 61, 49, 79. And our next set is 81, 79, 52, 48, 69, 39, 49, 89, 72, slow down, 81, 63. I didn't add anything, I just cut and pasted them.
Oh, yeah, can you see how the A and B don't have a 11 column?
It's absolutely fine because if we go back to these numbers right here, it's the same thing. Okay, so Do you have all this so far? Where'd I leave off?
You're on D.
52, 43, 52, 71, 88, 90, 39, 42, 29, 72, 72, 31, 56, 38, 89, bless you, 75, 62, 57, 39, 70, 65, 58, 92, 45, 58, 73, 94, 91, 66, 76, 65, 40, 62.
What'd you do?
No, that did not work. Nope, that's not what I wanted to do. I just want to see if something would work. It did not work. So now we're gonna list, we're gonna start with the values and we're going to list them. Yeah. What? Is there more in G? Oh, you're right. Sorry, G. 38. Oh, 38, 54, 79. So I zoomed in too much.
Oh.
79, 77, 59, 61, 39, 68, 56, 49, 46, 81, 40, 83, 60, 52, 53, 28, 65, 48, 37, 78, 58, 68, 63, 67, 75, 79, 67, 71, 60, 55. Let's see if that works. I'll try that one more time. Yeah.
What's their, so there's no 11 for A, B. It's
What do you mean?
like A, B, and I, there's no 11. Where the 11 from?
That's just, there just isn't.
Why is it something like A, B? Skips.
Because I cut and pasted it from Word. Because that's what it looks like in Word.
Does it matter what order they're in? Because I put it in,
No, as long as you have them.
okay,
It doesn't even
no, I
look
got
like
them
that
all
on
in, I
the-
just.
But I mean, we could do 63, 72, 58, 62, and 46, and we can get rid of those. I mean, we want it to be like in order or fancy. You could take all of these, Arial. You could take all of these,
Well, it's
and we
kind-
can make them all.
Yeah, that's similar to how mine's written, except the 78 is in column F,
That's okay.
which was just how I wrote it the same way that it showed up on the, right, on the other.
That doesn't work. Okay. Let's see. Okay, so the frequency, is the value and the times it happens. So we're gonna say 72. Now we can count them, but you know, that would be so like 2010. So I mean, why even do that? Or what we can do is before you type 72, you can go into conditional formatting, go new rule, format unique or duplicate values, format, fill, color. Oh no, it's not work right. No, hang on, it's different. It's conditional formatting, new rule. Format cells that contain cell value equal to 72, format, grab a color, okay, okay. And there's only one of them. So 72, frequency happens one time. And then you can just clear the rule. Just you go conditional formatting, their rules. So you just take all of these, just highlight them all. Conditional formatting, new rule, format values that are format cells based. Hang on. Format cells that contain cell value equal to, type your number, 68, format, pick a color, say okay, say okay. There's two of them. So what we're doing is we're saying how many times does the number repeat itself in the frequency? So we can count that by hand, but that would be like, so 2000. I'm having Excel tell us where they are. So it's highlighted 68 twice in the table, so I can do 68 happens.
There's more than 172.
Then I didn't do the rule right. Let's try that again.
I can see like 4 right now.
So I'm gonna clear the rule, clear rules. So let's take 70. So let's take the whole thing. And then conditional formatting, new rule. Format cells that contain cell value equal to 72. Format, pick a color. Okay. There you go. There's 4 72s. So the frequency is 4 times. It could be your version of Excel, maybe.
What did you do?
I'll show you. So I'm gonna highlight these again, and I'm gonna just go conditional formatting, clear rules from selected cells. So for 81, we just go, so we're gonna highlight the whole thing, and we're on 81 now. So we're gonna go conditional formatting, new rule, format cells that contain, and it says format cells, cell value, not between, just equal to, and we're on 81, right? So we're gonna say 81. We're gonna click on format, and we're gonna pick a color to fill in everything. So we'll pick green and say okay, and then okay again, and there's 4 81s. So then we know we can say 81 happens 4 times. And we can, of course, center these all so that it looks all nice and pretty.
I put 68 in and said there.
Really?
Yeah.
Okay, then let's see if I did that wrong. Let's go conditional formatting, clear rules, selected cells. And we were on 68, so let's go grab the whole thing. Make sure you grab the whole thing. So let's start. Yeah, this should be smaller so I can see the whole thing, okay? So I'm gonna do all of this, conditional formatting, and I'm gonna double check to make sure that I didn't miss anything. So I'm gonna say cells that contain equal to 72 and make sure I didn't miss any of them. Green, okay. There's only 4. Okay, that's great. Then you do Control Z, highlight that again, conditional formatting, new rule, format cells only that contain equal to 68, format, color, okay, okay. There's 3 68s, you're right. It's because I was zoomed in too much, I couldn't see it.
Yeah.
You can hit Control Z to get rid of the colors. Well, or you can just highlight the whole thing and just go conditional formatting, clear rules, selected cells 81. So we're going to go grab the whole thing. We're going to go conditional formatting, new rule, cells that contain equal to 81, format, color. Okay. We got 4 81s. Cool. We're going to take this and we're going to go conditional formatting, clear rules, 58. Or like I said, you can count them by hand, but I think that takes too much time. So we're gonna do 58. So we're gonna go conditional formatting, new rule, cells that contain cell value equal to 58, format, color. We have 1, 2, 3, we got 5 of those. 58, 5 times. Now what we can also do to save time is we can take and highlight a whole bunch like that, and then just do conditional formatting, new rule, unique or duplicate values, format, color. Okay. Now the reason I did that is what'll happen now is if we, as we're typing and looking at our data, it'll automatically tell me if we've already looked at that number, so we don't have to remember. Right here.
But when you make her do values,
In that column, and then it'll color code them for you. Conditional formatting, clear rules, selected cells. We are on 65. So I'm gonna take the whole thing, and we can type 65 here if we want, because I'm just gonna tell it to look right here. So how many times does 65 happen? New rule, format cells only that contain equal to 65. Okay, but I didn't add a color, so that didn't work. New rule, cells that contain equal to 65. Pick a color so you can see it. Green. Okay. There's 465. So frequency is 4. Is that making sense so far, everybody? Great. So the next one is 70. So we'll take all that and we'll clear all our rules. Additional formatting, clear rules, selected cells. And the next one is 70. Cool. How many times do we have 70? Additional formatting, new rule that contain equal to 70, format, color. Okay. Okay. There's 2 of them. Frequency distribution is twice. Take this. We'll go to conditional formatting, clear, selected. Next one's 83. I have 83 right here. And how many times do we have 83? Additional formatting, new rule, cells that contain equal to 83. Format, yellow, maybe this time. Okay. We got it in there twice. So frequency distribution, 2 times. Take the same thing. Additional formatting, clear. 74. So let's take 74 right here. And then let's go like this. Whole table. Additional formatting, new rule. Contain equal to on 74. Format, green. 1 time. Great. 1 time. Additional formatting. Clear. Let's do 58. Wait a second, we already did 58, so we don't do 58. So let's keep moving. All right, so let's do 65. We already did 65. How about 70? We already did 70. 83, we already did. 74, we already did. 58, 36. You 36 yet? I don't think so. 36. How many times is 36 in there? Additional formatting, new rule, cells that contain equal to, we're on 36. 36. Format, color, cool. Just 1 time. So 36 happens once. All right, let's go like that. Additional formatting, clear, selected. All right, 63. How many times 63 happen? We haven't done 63 yet, so let's do additional formatting, new rule, cells that contain equal to 63, format, color, okay, twice, cool, 2. All right, so now we're on our next column. So we're gonna take all these, additional formatting, clear rules, so cells. Okay, so now 49. So let's type 49 here. How many times is it distributed? Let's find out. Additional formatting, new rule, cells that contain equal to 49, format, pick a color to fill it with, green, okay, 4 times, easy enough, 4. Great. 73, is our next one. We have not done 73 yet. We'll take that. Clear, cells, additional formatting, new rule, cells that contain equal to 73, format, color. Let's find out. 2 of them. Great. 2. Let's clear rules. And we just did 73, so let's do 60. Did we already do 60? Not at 60. 60. Whole thing. Additional formatting, new, contain, equal to 60. Format. Go. Cool. It's in there 4 times. Great. 4. 93 is next. We're going to clear that out. Additional formatting, clear rules. 93. Did I miss 59? Oh, I did miss 15. 49, 76, yeah, 59. 59. Oh, because the 60 threw me off. So 59, how many times? Additional formatting, new rule, cells that contain. 59, format. 2. Distributions 2. We know we just did 60, so now we'll do 93. Formatting, clear, selected. Let's go conditional formatting, new rule. 2, 93, format. Great. just once. Cool. 93. One time. Like that. Conditional formatting. Clear rules. 32. Right, 32. Just make sure we haven't already done it. We have not. My time is 32 in there. Additional formatting. New rule. Cells that contain equal to 32. Format. Green. Go. Okay. Once. Great. Distribution is 1. 61. Did we do 61 yet? Let's find out. Nope. So we'll take this. We'll go clear. Clear selected cells. And that was 61. So new rule. Cells that contain equal to 61. Format. Green. Okay. Twice. Cool. 2 times frequency. All right. You have 49 already? We did. So we don't have to do, 49. So let's keep, so 79. Did we do 79 yet? Did not do 79 yet. So let's do 79. So we'll clear the rules. Additional formatting, new, obtain, equal to 79, right? 79. 79, format. 1, 2, 4 times. Cool. Did you do 72 yet? We did. So we're going to skip 72. And now we're going to do 81. Did we do 81 already? You're right, we did. So we're going to skip that one. How about 52? Oh. Yeah. We did 79. Let's do 52. Did not do 52 yet. So we'll clear all that. We'll go conditional formatting, clear, selected, and that is 52. Conditional formatting, new rule, obtain, equal to 52, right? Format, mean 4 times. All right, easy enough, 4. All right, did we do 48 yet? 48. Did not do 48 yet. Conditional formatting, clear cells, conditional formatting, new.
Was it 48 or was it 43?
48.
After the 52? No, it's
48.
48.
No, it's fine. It's fine. So take that. We'll go conditional formatting, new rule, use unique. I think I went too far. Cells that contain equal to 48, right? 48. Font, cool, color, twice. Distribution is twice. All right, so our next one's 69. We do 69 already. 69 did not. Okay, perfect. We'll go like this. We'll go conditional formatting, clear rules, clear, and then we'll go conditional formatting, new rule, cells that contain equal to 69. 69, format, green, okay. Just once, okay. It's only there 1 time. Awesome. 39. Did we do 39 yet? We did not. So we're going to do 39. Clear rules. Select cells, conditional formatting, new rule. Cells that contain equal to 39, right? 39. Green. Okay. 1, 2, 3, 4. Perfect. That's our frequency distribution. 30 happens 4 times. We'll go conditional formatting, clear, and we said 39. So we're gonna do 42. Do we do 42 yet? Maybe. No, 48. Yeah, we did. We did 69. We did 39. Did, no, 40, it'd be 49. 49, right? 49. Already did 49, so we don't have to do 49 again. So we did 39, 49. How about 89? Did 89 yet? I don't know, maybe. Nope, we did not. So we're gonna do 89. Take all that. Go conditional formatting, new rule. Cells that contain equal to 89, right? 89. Format set. Grab a color. Okay. Okay. There's two of them. Cool. 89 twice. All right, 72. I think we did 72 already. Yep. We're not going to do that. 81. Did 81. 58. We did 58. We did. Yep. All right. 52. Did we do 52 already? Let's find out. 52. We did. Yep.
What?
43. Did we do 43 yet? Not do 43. So let's do 43. Additional formatting, clear rules, cells. And that was 43, right? Rule. Contain equal to 43. Format, color. Okay. Okay. Just one time. All right. 43 only happens once. That's our frequency. All right. 52. But we just did that. 71. Did we do 71 yet? 71. Not do 71 yet. So let's do format, clear rules, select cells, conditional formatting, new rule, contain, equal to 71, format, color, show me, okay, twice. 72 twice, okay. 88, did not do 88 yet. Sometimes 88 occur in our numbers. Conditional formatting, clear cells, conditional formatting, new rule that contain equal to 88, format, color, once. Okay, that's our frequency right there, once. You do 90 already? Not do 90 yet. All right, so 90. Conditional formatting, clear cells, formatting, new, contain, equal to 90, format, color, okay. Only happens once, great, so 90 is one distribution. We did 39, I'm pretty sure we did 39. Yep, so we're not gonna do that. Did we do 42? I'm pretty sure we did do 42. No, we did not do 42. So we're gonna do 42. So conditional formatting, clear rules, and then we're gonna go formatting, new rule, cells that contain equal to 42. Show me the money. Okay, one time, great. It does kind of feel like bingo, doesn't it? Did we do 29 yet? 29, did not. So we'll take all these, clear, additional, new rule, cells that contain equal to 29, format, green, okay, one time, just once. 45. So 70, I know we did 72 because I can see it. How about 62? Not to 62 yet. So we'll take all that. We'll go conditional, clear, selected, new rule, contain, equal to 62, right? 62, format, color, it's fun, twice. 62 twice. All right, and now we're up to 31, column E, let's see, 31. Did not do 31 yet, so. Formatting, clear. Bless you. Just one time. So 156. Not do that one yet, so let's do 56. Conditional formatting, clear, clear, conditional formatting, near. Full. That was 56, yeah. Cells I contain equal to 56. Format, green, go, okay. Twice,
It's twice.
it's twice. I did that opposite or something, so that's twice. Okay, that's fine. We'll go like this. We'll go formatting, clear. Okay, 38, 38 yet. No, we did not do 38 yet. So frequency, new rule, contain equal to 38, format, blue, twice. So that is distribution 2. Do 89, maybe? We did. So we're gonna skip that one. How about 75? Do we do 75 yet? Not do 75. So let's do 75. Additional formatting, clear. Additional formatting, new rule, contain, equal to 75, format, twice. Distribution is 2. 62, I think we did 62. Let's find out. Yes, we did. So we're gonna leave that one alone. 57. Not do 57 yet. So we're gonna go like this. Additional formatting, clear rules. Additional formatting, new rule. Cells that contain equal to 57. Format, color. Just once. 7 once. Great. And then what's our next one? I know we did 39. I know we did. 39, 70. We can double check. 39, yeah, that's a problem. 70, yep, that's a problem. So we did both of those. How about 65 and 46? 65, yep. How about 46? Not do 46 yet. So let's do 46. Additional formatting, clear, clear, additional formatting, new rule, contain, equal to 46, format, colors. Okay, just one time. Great. Once. 92. Do 92 yet? 92. Did not. So let's do 92. All those. Formatting, the rules, edit cells, formatting, rule, contain, equal to 92. Format, color, cool, just once. Uh, 45, we do 45 yet? Not do 45 yet, so we'll do 45. Formatting, clear, selected cells, new, contain, to 45, green, just once. Pretty easy, 1, okay. 58, 73, I think we did those 58, yep, 73, yep. What's the next one? 94, 94 yet? 94? No, so we'll do 94. Clear. The rules, selected cells, conditional formatting, new rule, contain, equal to 94. Format, clear. One time. Mhm. So what I did is I took and I highlighted, like I went like really, I went like a couple hundred down. And then I did conditional formatting, I did new rule, and then I did unique or duplicate values. Format, unique or duplicate values, and then I said format, and then I gave it a color. And then I said, okay. So unique or duplicate value, so it's looking for the same number in that row, and that's why it changes color when I type it. You wanna see that again, Nikki?
That you go to unique rule.
You go new rule, format unique or duplicate values, format, pick a color, and say okay, and then say okay again. And then if you've gone far enough down in that row, if you type it, like if I type 45 now, it turns green. So we're on 90. Yep, no problem. So 91, additional formatting, clear rules, select the cells, additional formatting, new rule, 90. So we're on 94. So we're gonna do 91. 91, have not done that yet. Okay. 91. Formatting, new rule. Contain equal to 91. Show me. Cool. What do we have? Just one time. So that's just once. 66. We use 66 yet? Apparently not. All right, 66. Additional formatting. Clear rules. And then we're going to do 66. New rule. Cells that contain equal to 66. Format. Blue. Okay. That's one. $76. All right. Let's clear that. And let's see if we've used that. And it was 76. No. If not. So we're going to do 76. Conditional formatting, no rule. Contain equal to 76. Format. Okay. Okay. One time. All right. 65 and 40. Let's see. 65. Yep, that was a problem. 40. We did not do 40 yet, so let's do 40. 40. Additional formatting, clear rules. Additional formatting, new rule. Contain equal to 40. Format. Read twice. Okay. 40. Distribution is 2 times frequency distribution. 40. And then we have what, 83 next? 83 and then 60. So do we do 83 yet? We did. Did you do 60? We did 60. Yep. All right. So what else is next? It's 52. We've done it 53. 50. Oh yeah. Yes. Right. Yep. 38. 50, you're right. 54. We have not done. But we can double check. We can type it right here. Yep. We've not done 54. Formatting, new rule. Contain equal to 54. Format. Green. Go. Just one time. All right. And we'll go like this. Additional formatting. We'll go clear. Cells. 77. All right. So sure. No, that's fine. That's great. 77. New rule. Contain equal to 77. Format. Color. Doesn't really matter what color. Okay. One time. All right. We've done 59 and 61, haven't we? 59. Yep. We've done 61, I think, too.
Yeah.
Yep. Okay. 39, 68. I think we've done those two. 39. Yep. 68. Yep, okay, so we don't need to do those. 56, 49, I think we've done those two. 56, yep. 49,
Yeah.
yep, so we don't need to do those. All right, 81 and 40. I think we did both. Yep, I think we did 40 also. didn't we? 40, yeah. All right. 83, 60. I think we done both of those too. 83, yep. 60, yep. Okay. 52, 53. Pretty sure we did those too, but we can double check. 52. Yep. 53. Nope, not 53. Okay, but see, we're almost done. Additional formatting. There-
I'm just kidding.
It's faster than count when we count by hand, but equal to 53. Oh, okay. One time. 3, 1. Next one's gonna be 28. Formatting, new rule. Clear, selected. Additional formatting, new. Obtain. Equal to 28. Got it. One time. 137. Okay. Oh, all right. Okay, great. Yep. Okay, 37. Let's go. Additional formatting. Clear. Selected cells. Additional formatting. New rule. 37. Right. 37. 7. Format. Green. Okay. One time. Oh, the next one? Okay. I appreciate it. Thank you. 78, conditional formatting, new rule. Contain equal to 78. Format. Just one. I did the format weird or something, but 78. 1. Okay. All right. Cool. Clear. Clear. 60, what did you say? The next one is what? 67? Additional formatting, new rule. Twice. Twice. 55. And how many times is 55 in there? So additional formatting, clear rules from selected cells. Now let's go additional formatting, new rule, contain equal to 55, color. Great. One time. That is your frequency distribution. Done with that part.
That part?
Yeah, the other stuff's fast though. So what else do they ask us to do? Central tendency, mean, median, mode, standard deviation. And then variability, range, standard deviation, and variability. And then SPSS. Yeah, this gonna be homework. I have it posted, or I can show you how to do it.
No,
You should show us.
Yeah. Do that. 3 measures of central tendency, mean, median, mode, standard deviation. So
Is there enough time though?
if we use Excel, there's enough time. If we do it by hand, then, but I want you guys to know how to be able to do it.
Yeah.
So, well, actually, it's pretty easy because we go, so the mean, right? That's very easy. We just take all the numbers and we can sum them. Not 3154, that's fine. And then we don't know how many, I just highlighted them and hit sum. And then we don't know how many we have, but we can, right here, auto sum.
Oh,
So then we can go equals count like this, and then we can go like this, all the way to, except for our total, and then go like that. And then our count is 51, so we take, so we just, this is what, B 67. So equals B 67 divided by 51. So that, this would be our mean. You see how I did that? Because I told it to count how many numbers we had. I told Excel to count all these numbers for us by typing in count and the range. Or we could say equals average, like this,
Sum divided by the,
total number, or we could just highlight them and tell Excel to do it for us. And that would be the same exact mean with Excel.
whoa. How'd you do the thing, the second?
This one,
Why'd you say mean of itself?
because I did a formula. This is the total sum divided by 51 numbers. This is telling Excel how to do it. What else do they want? They wanted mode and standard deviation. Mean, median, mode, and standard deviation. So mode, that's real easy. So we got 4, we got 5. I would say our mode's 58. Because I don't see any other 5s in the list. Because so 58 is our mode. Because that repeats itself, right? The most amount of time. So it's unimodal, 58. Then what else do we have to do? Standard deviation, not a big deal. If we do Excel, it's faster. So we could do, if we wanted the standard deviation, we could just do standard deviation. So we could say equals ST dev S dev P and we go like that. And that's our standard deviation, but this is our standard deviation population. SD pop. And if you wanted to be fancy, you could do what is our standard deviation sample. That's very easy. We could just type in equals stdev.s range. And that's our standard deviation sample. Or we're gonna do it by hand. That's those. Variability range, standard deviation, and variability. So we can take the variance, var.p, and we can take the range. That is our var.p is your formula, enter. That's our variance population. And then if we want our variance, the var.s, and do our range, and that would be our variance sample. And they're close, so that makes sense.
That's variance.s.
var.s for sample, and then your brackets in your range. And then, so we did standard deviation, we did the variability. So the range, so we just did the standard deviation. I don't know why they said so. All we have left is the range. That's easy. So we could just go just take all of these, and then we can just go over here, data, and then we can do filter, expand. Lowest number is 28, highest number is 94. 94 minus 28 is what? That's our range. I just told Excel to sort these in order. So 94 minus 28 is what? 94 is 28. So our range is now, so our range is 66. I just checked that, that's right. And then 3 measures of variability, central tendency, and the graph. So that's pretty easy. So what we can do is we can go in here. We can take, I can undo that. And then I can just take this and this all the way to here, home, data, page, insert, creature it's really. Charts, yeah. So we could graph it like as a bar chart, like that. And then we get to type in. What?
I'm not getting any of it.
Oh, on these?
Yeah.
So these are those are the formulas. So your variance is equals VAR dot P bracket VAR dot P bracket, and then the first number, comma, and your second number, VAR dot S is for your sample. The range, I had Excel sort, and Excel told me the smallest number was 28, largest number was 94. So I subtracted those and I got 66 for my range. We could finish this next time.
I saw you doing it. Where you were highlighting.
Yeah, so like, yeah, if I plug this in, and then I highlighted all those. That's your population. That's your sample.
What's the 51?
That is the count of all the numbers, and there's 51 numbers for our n. This is basically like our n. So we did tendency, mean, mode, standard deviation, range, standard variability. Oh, yeah, then it's just SPSS, which is.
Do we just copy and paste it on this?
I think you can take your numbers.
When we do, it's funny.
What?
Remember how when we first did it, we had to do it,
What do you enter?
Oh, we can put that into SPS.
like as a link.
You can, or what you could do is you could take all these numbers right here. Let's clear the rule, selected cells, take all the numbers, Control C, file, new, blank workbook, Control V. Come on, Excel, Control C, Control V. Take all the numbers like that, you go file, save as, browse. I'll save it as a CSV file. We'll call it assignment 3, 4. Yeah, great, awesome. Glad save. No, that's fine. Cancel. Go into untitled file, new, data, file, import, Excel, and then we just need to find where it is, downloads, CSV. We'll just save it as an Excel file, and that's fine. It might be, yeah. File, import data. So documents, assign, there we go, open. Great, awesome, next, finish, cool, bam, done. And then, oh, that didn't really work the way I wanted that to work. It's giving me multiple ones. So what we could do is we could just take this, Control V, Control X, Control V, Control X, watch. I know we're a little over on time, but I can probably, in about 3 minutes tops, show you the rest of the assignment if you're able to stay. It's late for me too. I've been going since 8 a.m. I'm doing Control X, Control V. I'm cutting and pasting into one giant column on purpose for Excel with all of our numbers. Yeah.
So you're just putting it all into one column.
Put this all, if I put this all in one column,
Does it make it easier for
Control
SPSS
X.
to read
wow.
or to input?
So what we could do is we can go File, Save As, Documents, Excel, save, go into SPSS, File, New, Data, File, Import, Excel, and we'll grab that, open, it's fine. Oh, it didn't like the name. Okay, fine. File, save as, documents, save, Excel, file, import, Excel, grab, open. Oh, we'll do it next time. That's fine. Not this, no, we'll go over it. For the next one. Just the worksheet and WebAssign for pre-test, post-test, chapter 4, post-test, chapter 3, WebAssign, chapter 4. And then we'll do the last couple steps of this. We'll hand it in, and then we'll go into chapter 5, probability. And then the next class, or I'll give you time, but probably the next class, I'll have you all present your understanding of 1 through 4, and then we'll have a test in about a week and a half, 2 weeks on the first 4 chapters. No, like what? Presentation, and then you present after that. So in like about 2 weeks or so, or 2.5 weeks, we'll have a test 1 through 4, and then in like a month we'll have tests probably 5 through 8. Then a month later, probably 9 through 12.
Are the tests online or are they in class?
Online, unlimited time, and I'll tell you how long you have to take it. 2 attempts, and I take the highest score.
Yeah, I just wasn't sure if you were doing them in class or online.
No,
Because I have classes that do both.
What was that?
Oh, I just said I have classes that do both. Like this one does them online, but then like my phlebotomy class, they're online, but we have to do them in class.
That's weird.
I don't know why.
No, it's fine online because none of you get the same test.
Yeah.
See you later.
Have a good night.
Yep.
After you do the first attempt, are you able to see your score, or do you just have a second attempt?
You can see your score.
Okay. Have a good night.
You too. But I'm not assigning. It's just chapter 3 and chapter 4 stuff. That's it.
Well, have a wonderful night.
You too.
Good night.
You too. File, new data. There we go. Yeah, now, of course, now it works. So you would literally just cut and paste it in there. Descriptives, you move it over. Options. No, not descriptives. You would just, if you're interested, you just say analyze. Descriptive statistics, frequencies, move it over statistics, mean, median, mode. Those are central tendencies, standard deviation, range. Continue. Okay. And there you go. It spits it out. And that's the last piece I can show you guys, but that's fine. I'll recap like the last couple of pieces of that. Next class, but I think I'm going to email myself a copy of this book. Save as documents for the frequency, because I don't want to redo that whole thing. Frequency. Let's go online. New frequency.
What we did today, would that be like the test?
Yes, but it is absolutely recorded. I absolutely have a YouTube